So my friend Leo Mayarovich and I recently wrote a post on vector databases, which was mostly me exploring this area. And I was quite pleasantly surprised how popular and well received this post was and is. And so today we have one of the leading open source projects in this space and one of its creators to walk us through what we got right and what we may have missed in that post. So today we have Bob Van Luijt. He is the CEO and co-founder of SeMI Technologies, which is the company behind the open source vector search engine Weaviate. Bob, welcome to the Data Exchange podcast.
Thank you so much for having me. And thank you for writing the article.
Yes, yeah. So first, I always like to start by quoting what you have on your website. Okay, so this is what you have on your website. We believe that the next wave of software infrastructure is AI first, and that a strong open source community is a basis for creating high quality software. Our flagship product is the vector search engine Weaviate. So two things there: open source, vector search engine, which, by the way, Bob, let's start here with the terminology. So we called our post the vector database index, but I know that not everything we had in there was a database. Some were just libraries, some were just indexes. But it would have been odd to have like a long title, the vector database and libraries index, right? So, but now, as we wrote the post, it became clear to me that search is actually at the heart of what all these systems are trying to serve. And so you specifically, in your description of Weaviate, you call yourself a vector search engine. So talk to me about the notion of what exactly are these systems supposed to be? Are they supposed to be focused primarily on search, or are they more broad?
So great question. So first of all, the reason we choose the terminology search engine, because search engine is a flavor of database. So if I use the term database, then okay, that gives a differentiator between like framework and database. But what kind of a database? Are we talking about a time series database, a graph database, a data warehouse? So if you would say Weaviate is a database, you're factually correct. But we've
or as your other people in the space say, they are a vector database.
Yes, and the reason why we've said vector search engine, because if you say vector database, you're not very descriptive. I once spoke with one of the founders of a very big data warehouse, and he made a joke and he said like, well, we have a vector database as well, because you could just store your vectors in our database. And that was a little bit tongue in cheek. That was a little bit of a joke, but I agreed actually with him, because I said like, I think you need to be very descriptive what you do. And so for example, you also have like feature stores where you can also store vectors. We really focus on search and things that are related to search. And the innovation, in my opinion,
which I guess in the computer science world is information retrieval.
Fair enough. Yeah, right, information retrieval, right? So, or search depends a little bit on how you define that. And the thing that started to happen was twofold. So first, the embedding, the similarity search that we could do based on the embedding coming from the machine learning models. So you throw, for example, text or an image at the model outputs a vector embedding. We could do similarity search based on that. So show me similar images, show me similar texts, and those kind of things. That was the first thing that was like the opportunity.
So before we dive in further, so historically, obviously, things started around things centered around text, because after all, the first thing was Word 2vec.
Yes. Yes.
So then, so right now, Bob, if you were to look at your users, what's the breakdown as far as data type?
So most by far text, by far, then images, and then what I like to call esoteric use cases.
So how dominant is text? Is it like 80%? text?
Let's roughly 75, 20, 5%. So 75 text, 20 images, 5% other types of embeddings.
So at what point did people have enough of these embeddings that they decided we need more than just a file system?
So, great
I
question.
mean,
So,
and I guess let me reframe that. So rather than time period in time, at what point does a teams decide, like how many of these embeddings do we have to have before we start considering we need something?
so that kind of started to happen with the boom in like with Hugging Face making these models available, but also OpenAI introducing the embeddings endpoint and those kind of things. And people started to understand, hey, I can use these embeddings for search. And secondly, the quality of these embeddings went up, like significantly. So when I started working on Weaviate, I was using Word2Vec, but the results were like still so. And then when the whole transformers architecture like basically hit the market and people were able to get easy access to these kinds of embeddings,
So
then it exploded.
were you always historically focused on search?
Not per se. I got very intrigued with similarity search and just what we could do with these embeddings. Plus, I was intrigued by we saw some marketing content, I guess, coming from big companies like Google, etc., where they said like, "Hey, we're gonna move to AI first with our search engine," and I was like, "What does that mean?" And then quickly, I started figuring, "Hey, that's related to these embeddings. Hey, can I make something available for others to use?" So that is basically also how Weaviate was born. But the thing is, if people make these embeddings, right? So you might argue, why not store them indeed in a framework, or why not store them just in my
So
in the
as
Python
we
script?
point out in our post, why not store it in an existing system like Elasticsearch or Lakehouse, or assuming they provide you with the right indexes, right? So
It go even a step further. That is how I got started, by exactly asking that question and playing around with that. And the thing that started to happen was that to really scale vector search, so the algorithms that you need and the algorithms that were entering, like that were coming out of the academic sphere, basically, learned us like, hey, we need to have different ways of storing this information, because just doing it brute force, that's not scaling. So we needed these approximate nearest neighbor algorithms. First, they came out of research in the form of libraries, where people could, for example, build these indexes, work with them. You had from Spotify, you had Annoy, you have, of course, from Facebook, you have Vice. And then logically, the next iteration was that people said, yeah, but wait a second, I want to have database support. I want to have CRUD support. I want to be able to create, read, update, and delete these objects. I want to make sure that they're persistent. I want to be able to shard them. I want to add text objects to them, etc., etc.
so now you're getting into topics that a lot of people are more familiar with. So when you're talking data management systems, as you point out, so what are the things that people start asking? Scalability, right? Throughput, latency, um, ecosystem. Like, does it connect? Who can connect with it? Who can talk with it? Query language, all of this. But as we noted in our post, when we looked at these systems, it seems like right now, and I may be wrong, correct me, Bob, a lot of the systems seem to be focused on scaling, because it seems like uh, you can easily handle several millions of these embeddings, but then at some point you have more and more, maybe you get to the billions or whatever. So am I wrong to think that a lot of the focus in this community is in scale right now?
I wouldn't say per se wrong, because of course it's important to bear in mind that people are used to existing systems, and they so if you use Mongo, if you use Elastic or those kind of things, you have a certain, you expect something from a database. So that is something we see as well. People expect certain things, and we try to level up to that, and try to make sure that we are in line with that. I think the most important thing right now could be captured in an amazing UX.
Okay.
So to help people to understand how they easily can use the database, index their data with the machine learning models, and search through them.
And Bob, who would be, so at least for Weaviate, which you know really well, and maybe perhaps you also talk to these other communities. So who is the primary owner or user of the system? Because the embeddings come from the ML teams, maybe, right? So, but then traditionally, data management, that's a platform team responsibility, right? So who's your target user at this point? Is it like a software engineer developer? Is it mostly data engineer, ML engineer?
Great question. We did a survey with our community, and well over 70% of people identified as software engineer.
Okay, oh, that's interesting. So then, so at what point do these because software engineers may not know about embeddings, right?
That is correct. And this is what I meant with that UX point. So people are tasked with building better search solutions or better recommendation engines. They just get that as a task. So that can be an e-commerce platform or document search platform, whatever you can think of. And they go like, hey, wait a second, I can use these models, to search.
So there's enough things that if you're a software engineer, you Google around, you stumble upon, hey, I should be using embeddings.
We can always do more, but it starts. So on a serious note, like about 9 months, a little or maybe a year ago, there was this inflection point where people seemed to start to get it. So where there was a lot of push from ourselves and our peers in the space to the market, people started to more come to us. It's like, okay, we get it. We know what we can do with this. Help us to scale it. Help us to index the data and those kind of things. And
does that mean that? So that means that if I'm a software engineer in some company and someone tasks me with improving search, I do some research, I stumble upon embeddings at this point. So then what's my natural entry point? So my suspicion is first thing they'll try is some library like Face, right? And then go from there, unless you guys have done such a great job with open source Weaviate that you become the first thing they try, right?
So actually, we see a different journey.
Okay.
So the software engineers and the data scientists are very different here. So a data scientist might say, okay, I have these embeddings and I want to just do similarity search on them. They might take that route of Face or
NN from Google.
Yes.
Yeah.
Exactly. All those that are there. Yeah. But what we see with our large group of software engineers, they actually look at the incumbent players, right? The existing players.
Elastic.
Yes.
Yeah.
And then they run into they have questions, or they sometimes run.
And it's also not an area it's not an area of focus, right?
Exactly. And that is how they often come to Weaviate. That they go like, we want to scale this. We want to have something that is natively built.
So I caught you again there. You use scale. See?
Yeah. Oh, so shit. Yeah.
So my thesis is right. This space is scale obsessed.
That's a fair point. I hope I'm trying my best to be UX obsessed.
Okay.
So to make it as easy as possible for people to use this. And what
UX for a software engineer means different things, right? So that's operational complexity, API integration, right? So define more clearly for our audience, when you say you want to improve UX, so what exactly are you doing?
So I literally mean everything that our users are interacting with. So the first thing that they read on the Weaviate documentation. So does that convince them like, hey, this is a solution to my problem? The way we teach them how Weaviate works is that not too much new information from what they're used to. The way that we've defined the syntax in our APIs, the way that they can run it and play around with it, all these things combined, all these things together, that makes the UX, right, of the solution. If one of my colleagues gives a talk at a conference, the way that they present the solution, that people go, oh, I get it. This is for me. This is like, it uses my language, how I understand, databases and software engineering. Everything that, gives an experience about Weaviate. And I find that extremely important.
And so then ultimately the end user of a search engine of which Weaviate may be the back end uses a text box. So, right, so it's similarity search at the end. Semantic search, right?
No, but what you're saying is right. So you do semantic search based on similarity search. So in the end, it all boils down to similarity search, but, and this is really important, and this is a really big differentiator in like a search engine that we're building, what we know is that if you want to do, for example, semantic search, best results are coming from mixing semantic search with traditional search filters. That yields by far the best results. So what we believe also as Weaviate is, and that's also something we're doing and that people can see in our roadmap, that is the direction that we're going into. So yes, at the heart sits the similarity search engine, and then you build up from that. And that is the beautiful thing of having an open source community, because they tell you what they need to solve their problems. And that's what they told us.
So what are the programming languages that you're targeting for developers?
Yeah, so currently we have clients for Python, Go, JavaScript, Java, and I saw somebody created a PHP.
So rank them in order of popularity for Weaviate users.
I might be wrong, but it's Python, JavaScript, and then PHP, Java at the bottom.
So when you think of traditional data management and database systems, usually you have this breakdown, right? Based on workload, OLTP, transactional, OLAP, analytics. So where does a vector search engine live in this kind of dichotomy, or does it not sit in this dichotomy? In other words, can I use Weaviate to run reports?
Yes, you can.
Or does it even make sense? But do people do that? I guess I don't know, right?
Exactly, people don't really do that. So the what you're describing sits more in the what I would like to call the relational database management systems, right? So often like with SQL languages and those kind of things, we really sit more in the NoSQL space. So where you sit with the with the Mongos, the Elastics, the Solars, and what have you of this world, that is more where we sit. It's also more API based, whereas these data warehouses are more SQL based. Right. So the way that people interact with it is different. So we see people create solutions for e-commerce integrations, document search,
recommendations,
recommendation engines. We see a lot of people build recommendation engines.
So you use the phrase vector search engine, but if you break down by use cases, so I'm assuming search is overwhelmingly number one, right?
Yes.
But then what's 2 and 3?
So I would say there are 2. So one is search, just finding something. And the other one is recommendation. And recommendation is done based on something similar.
Which is kind of like a search, right? So in some ways, right? Because basically I'm interested in this book. Well, here's this book plus other books you might be interested in.
Yep. I saw somebody, to give you a very simple example, I saw somebody who was playing around with, and it was just, somebody was playing around with it, so I can share this. With a plugin, a Chrome plugin, and this person loaded a few books into Weaviate, And then if you were reading a website, you could select the text on the website that you liked. And then the Chrome plugin would show you what books were that were based on their description similar to the text that you're selected. That is a great example of a use case for similarity search as opposed to just pure search.
So when you talk of search and recommendations, the other thing that comes up is freshness and recency in real time. So is Weaviate and systems like Weaviate, are they meant for kind of being up to date with the most recent information?
Depends how you look at it. So when it comes to loading it in the database, yes. However, the model that you use to create your embeddings is as fresh as when the model was trained or fine-tuned. So that's the caveat there, right? So
but once the embedding is loaded in the database, then the Weaviate can basically add it to its rankings.
Yes, and this is something that's very important differentiator as opposed to these libraries, because most of the libraries, they create immutable indexes. So if you want to change the index, you need to rebuild it, which might take hours up to days. But the database does real time.
I see. So then one of the things I pointed out in the post, and I don't know if it's actually true, I just kind of assumed that this was it's that and I guess this is based on conversations with other people in this area, is that most of these systems assume you already have the embeddings. So in other words, they don't necessarily provide you with tools to create the embeddings. Let's say you have 1 billion images or 1 billion documents, then it's your job to do the embeddings, and then they step in. And then that's why I speculated that tools like Ray might be helpful, because it could help you scale out this embedding computation process. Am I correct with this assumption?
Yeah, and you're not even correct with the assumption. You're describing basically what we're doing, because in Weaviate, if you use Weaviate standalone, you need to bring your own embedding. But we also have modules, so Hugging Face, OpenAI, etc., where you basically can say, do the vectorization for me. So you say, like, I want that, for example, sentence transformer loaded into a Weaviate module. And now if you load your data into Weaviate,
but you have to be able to do this fast, because you might have to experiment, right? So
yeah, and that is why
not pick the right embedding right off the bat, right?
Exactly, and that is why we in the modules, the Weaviate modules, are also looking at and working with Ray inside the modules.
Great, and full disclosure to our audience, I am an advisor to Anyscale.
Oh no, great, and tell them that we love what they're working on.
Yeah. And so then, Bob, what is the difference between Weaviate open source and what SeMI Technologies offers? So is there a big difference between the open source Weaviate and the hosted or proprietary Weaviate?
No, there's no difference from a bits and bytes perspective. The difference sits in the fact that the SLAs that we offer and the service that we offer around hosting it. That's the big difference.
Yeah. So if you use the hosted service, boom, you're ready to go, right?
Yes, sir.
And then it's the most up to date thing, and so but then so one of the things that I noticed too, based on scouring your blog, is that you also focus a lot on the actual algorithms, I guess, the approximate nearest neighbor algorithm. So there's HNSW, but then so how fast moving is the space of the algorithms for nearest neighbors? Is there a lot of activity there, or is it mostly people use the same thing?
So most people currently use the same thing, but there's also a lot of stuff happening in that space. And,
So is there a lot of academic research that you guys have to stay on top of?
Yeah. So the article that you're referring to is written by my colleague Abdel, who's a researcher at SeMI, and he basically takes that academic research and figures out how we can bring that to our users again with an amazing UX, because that's the That's a must.
And so then, what is on the near-term roadmap of Weaviate?
Yeah. So on the near-term roadmap, the two most important things are one, a hybrid search, so that just with one query, the database automatically figures out what to do in vector space and what to do with more traditional filters. That's one. And the second thing that is on the semi-near roadmap is indeed bringing the vectors from memory to disk. That was in the article that you were describing.
Yeah. That other systems seem to be moving towards, right? So at least to fast SSDs, right?
Yes, exactly.
And so what's the timeline for these two things?
So the first one is this year, and we're already in the last
This
quarter.
year is almost done.
Yeah. So it's going very fast.
Yeah.
And we already have prototypes for disk, so that will be soonish. But I'm not expecting that this year. But it's going pretty fast, to be honest.
And so then, what kind of industries and company profiles, if you're comfortable sharing, you give us a sense of who are the early adopters of this technology. Are they mostly tech companies, or it's all over the place? Is it mostly in finance? Is it mostly in advertising? So give us a sense of who are the early adopters of these vector search technologies.
Yeah. So the good news is that it's literally all over the place. So I'm very happy with that, right? So you see this kind of horizontal adoption. The big difference is that with the smaller players, i.e. the startups, they use it to really build new startups on top of the database. And with the bigger companies, they just want to enhance what they currently have. That's the big differentiator that we see. And again, the majority are software developers.
I see. And you folks are committed to becoming to remaining a pure infrastructure company. In other words, you're not going to go into applications, like you're not going to build like a medical search engine.
So as we look at it now, the focus is really on being infrastructure based. I know of a user who's building a medical search engine on top of Weaviate. So we want to enable people to build these new types of search engines. So as I look at it now, yes, we will keep focusing on delivering that infrastructure to build ML first search experiences.
So since these embeddings are so magical, why not? So the thing that I guess counterintuitive to me to what you've repeated a few times here is that in reality, hybrid works better than purely just using embeddings. Is this kind of an accepted thing inside this space? Or are you folks kind of somewhat doing something counterintuitive?
No. We're not doing something counterintuitive, and the research suggests it. But what I find even more important than that the research is suggesting it, our users are getting more value out of it.
And so the Weaviate makes it easy for you to. Is there a knob which says, weigh embeddings more than traditional?
Yeah.
Okay.
Yeah. And we're gonna add a ton of more features there. So we also have like a product research team, and my colleagues Laura and Connor are in that, and that is exactly what they are investigating. So what are the tools and the features that we need to give to these users to make it as easy as possible for them to use the best of both worlds, basically.
By the way, this is one of these things, vector search, and to some extent, I put time series databases in this category as well. It's one of these are things that some developer or software engineer will say, you know what, I don't need to use any of these existing systems. I can just build my own, and then they probably can build their own rather quickly, but it's adding features, maintaining, scaling, right? So it's one of these things that you can scratch your itch, but you're better off leveraging something that already exists, that's focused, that has a community, right?
Absolutely. And I am an example of that, right? So I thought, let's just build something. And then I was like, oh shit, this is actually a lot of work. But the thing is, the reason why I believe that we now see these vector search engines or vector databases is because the way that the index is built at the heart, that is just conceptually completely different than how existing search technology is doing that. So it's like there was just room in the market, if you will, to approach the problem from a different angle. That is why I believe that they exist, and that the same goes for Weaviate. So if you believe that the world is moving towards what I like to call ML first, which means we start from the perspective of that embedding, and then we work our way down from there. Then you need new technology that does that for you, and here we go, the magic word that scales that for you.
Yeah. And that's why actually we pointed that out in our post, that basically embeddings are fundamental to ML and AI. So you need to have a strategy around these embeddings.
Yes, that
right?
is absolutely correct. Yes.
And you can't just kind of improvise. I mean, you can in the beginning, but over time it becomes harder, right?
Yep, that's correct.
Yeah. And so then let's see. In terms of trends in the broader machine learning space, one thing that seems to be happening is this notion of multimodality, right? So models that rely on many different data types. And since all these data types have embeddings, so it seems like systems like Weaviate are well positioned for a world of multimodality.
Yep, that is correct. Yep.
And so then, are you starting to see people doing that?
Yeah, sure. I think the first thing that we saw, what was the first hint towards that was when the clip model was released, and where people started to store that in Weaviate, you do that in different classes. So where people started to store that in different classes and started to mix and match these results, that was the first hint that we saw that people started to do that, and it's now going very fast. So we knew that was going to happen, and the way that the Weaviate index is built, it's able to support multi-model models. So that is possible. Yeah.
So then, one of the data types that I feel underappreciated, and I happen to be involved with a new startup in this area, is audio, so speech technologies and stuff. So you're not seeing that yet.
I am seeing it, and now I have to do something that's unfortunate for a podcast, but I've seen something very cool with that. And I hope very soon that they can also share their story with the outside world, what they're doing there with audio. But we see that people start to become more and more comfortable of like, oh, so this is what embeddings do. So now I can use a wave to VEC model or a video to VEC model and those kind of things. But that is happening. It's growing. And I agree with you. That's still undervalued. Yeah.
So what remains in terms of education and evangelism for you? So are we at the point, Bob, where when you go to a company, you don't need to explain what you do anymore, or there's still a lot of, hey, this is what an embedding is, and this is what these new systems like Weaviate can do, or pretty much people already are aware of all of this?
No, people are not, and I think that is one of the biggest mistakes that I'm sometimes making on a daily basis, is that I assume too much, that people know too much, right? So we sometimes really have to go, back and explain and show people, okay, this is what an embedding is, this is where you're getting it from, this is how you store it, and those kind of things. So there's a lot of work that still needs to be done there. I also I'm always saying like, hey, we do that with all the peers in the vector search space. We're basically helping each other to educate the market what needs to happen. But it's like I'm sometimes even today still surprised that I'm thinking like, okay, there's a lot of work for us to do in educating the market.
So Leo and I close our post with by speculating on the future of these systems, right? So In other words, platform teams always want to have fewer systems to maintain and operate, and so at some point, we wondered out loud: would it be possible for broader systems like Elastic or these lake houses to take on some of these capabilities? Now, I know you're probably going to say no.
No. I'm willing to give a truthful answer here.
Yeah.
No. The answer is not only yes to that question, that they are. I recently tweeted something about the SEC filing of Elastic, the recent quarter, where they literally say that they see vector search as a new thing in the market. But the thing is this, Ben, when you build these, the reason that we see so many databases in the world is because every time you're working on it, you need to make architectural trade-offs. You need to make decisions like, why isn't that just one big Postgres database that solves all the problems of the world? Well, because you make trade-offs to make these databases as something that you want in a data warehouse versus what you want in a search engine. I strongly believe that everything based on embeddings needs different core architectures to support the use cases that people have. So a time series database is different from a data warehouse just for the way that it's architected. So I really believe these approximate nearest neighbor or vector search solutions who have vector search at the core is just a new niche in the database market that people will want to use if they want to build ML first solutions. So yes, it will be part as of incumbent players or existing databases. But if you really want to build something from the perspective of, again, here comes the word, scaling that, then then you need a vector search engine.
So, by the way, I should have asked you this question from the get-go, but at a high level, architecturally, these modern lake houses now separate storage from compute, right?
Yeah.
So for systems like Weaviate, do you do something like that? You have storage and compute, and the compute will have all these libraries. So how is Weaviate architected?
So so this is actually a difficult question because that's a lot that's in there, right? So the first thing is to say as like an asterisk that these data warehouses have a lot of history, right? So they're old basically. So that is not the case yet with these vector search engines. So they're pretty new how they're.
Yeah, and the reason I ask is I may start out with I already have 1 billion images in some S3
Exactly
storage, right? So then do I just point Weaviate to that?
Yeah, so in some cases you can, and we see a lot of community users building that kind of.
But then from there I have to generate the embeddings that will get stored also where in S3, right? So
So no, then the embeddings would be stored in Weaviate, but that is what I meant. Why it's a difficult question because we're now learning from the community how they want to do that, and an upside that we have as opposed to these incumbent players is that Weaviate is. So the words are like cloud native, right? But what do we mean with that? Well, we mean it is like containerized and it easily scales and runs on like Kubernetes platforms. To the origin of your question, makes it easier for people doing ops to run these kinds of systems.
What is the storage engine? And the reason I ask is the Pinecone folks who I've talked to have kind of made a big deal of how they went from RocksDB to now they have their own proprietary storage engine written in Rust. So
our technology is not proprietary, so people can see it. So Weaviate is also written completely. We don't rely on anything. It's completely written from the ground up. So it has in our case now the HNSW index, which is plug and playable. So later we can add other indexes. And the inverted index that we need is also completely written from the ground up. And if you look at our GitHub, you can even go as deep as that you see certain assembly integrations to optimize. So we don't rely on anything. It's completely written from the ground up and it's open source, so everybody can take a look at it.
And so Anything else, Bob, in closing? So what else are you excited about in terms of the broader AI and ML space that you think you'll need to kind of accommodate or adopt into Weaviate?
That goes back to that UX part, that the community is around Weaviate is rapidly growing, and these people tell us what they need. So he said, I have these models and I want Weaviate to do X, Y, and Z. So the coming year, we're going to see a lot of features being added to Weaviate that help these people to make it as easy as possible, great UX, to solve their search and recommendation problems. So this is everybody in this space, we're just getting started.
By the way, with the hosted service of Weaviate, I guess not only do you have all these improvements in UX, well, operationally it should be simpler because they take care of everything for you.
Yes, exactly. Exactly.
And with that, thank you, Bob.
Thanks for having me, Ben.